Assalamualaikum and good evening to Mr. Safi bin Manan and everyone who are watching this video. So in this video, we will do a presentation about the washing machine that are being created by using Autodesk Inventor. And the code for this subject is DJJ30122. Before I start this presentation, at first I will introduce myself and my group members. My name is Muhammad Nazam bin Ibrahim, and my other three members is Ariandi, Dedi, and also Zamzar. Computer aided design, or in short form, CAD, it's referred to the use of computer technology to assist in creation, modification, analysis, or optimizing of a design. Typically, in the field of engineering, architect, and product design, CAD software always allows user to create detailed 2D or 3D model of object and structure, aiding in visualization and precise the design process. So we use Autodesk Inventor to create 15 part of the washing machine, and Autodesk Inventor is a popular computer-aided design CAD software, and Autodesk Inventor is a professional-grade 3D mechanical design and product simulation software commonly used in engineering and manufacturing industry. Users leverage Autodesk Inventor to create detailed 3D model, simulate product performance, and generate engineering documentation. So there will be a 15 part of washing machine in the next slide. So let's move to the next slide. So this is the first part of the washing machine, and it's a very important part of the washing machine. And first we make a sketch with 180 rectangle and also 200 millimeter rectangle, and then we extrude it with 200 millimeter, and then we sketch back at the top of the body part, and then we make a 180 millimeter, and then we extrude cut the rectangle. Then after that we make a fillet at the edges of the inner and the outer of the body part, and then we take the one side of the body part and make a hole with 120 diameter, and also we make a tiny rectangle with 25 and 10 millimeter, and we extrude cut it, and then this body part was created. Then this is the second part of the washing machine. This is the top part for the top of the body part, and then first we make a sketch of 200 rectangle, and then we extrude it with 10 millimeter to the top, and then we make a sketch on the top of the top part and make a 50 and 15 rectangle, and also a 60 and 25 rectangle, and then we extrude it with 5 millimeter, and then at the bottom part of the top part we make a 180 rectangle and extrude it with 5 millimeter, and then at the top part of the top we make the rectangle for the screen for the washing machine. So for the third part, we design a bottom part so it connected to the body part of the washing machine. So at first we make a rectangle of 200 and also rectangle of 180, and then on the between of 180 and 200 we make an extrude to the top with 15 millimeter, and then on the 180 we extrude it with 20 millimeter to the top, and then at the each edges of the rectangle we make a fillet with 15 millimeter, and then we make a small diameter on the top of the bottom part with 2 mm diameter, and then make a thread on it. Then on the bottom part of the bottom part, for the leg of the bottom part, we make a 15 diameter, then we extrude it with 7 millimeter. So this part will connect it to the top part of the washing machine as a screen. And the first step we do this with, we make a rectangle with 50 and 15 millimeter, and then we extrude it with 5 millimeter, and then we add an image to the top of it, and then make it as a screen for controlling the washing machine.
For this door part, we do a sketch with diameter 130, 120, 110, and then we extrude the 130 diameter to 10 mm. After that, 120 diameter, we extrude 20 mm to top, and the last diameter is 110, extrude to the down with 5 mm. We also fillet the 100 diameter edges with 2 mm fillet. We use XY plane to do a door holder and the hinge so it connected to the machine. Next, door glass part. For this part, we sketch 110 diameter and also 90 diameter. And we extrude to the top with 50 mm. For the 90 diameter, we extrude cut S, deep 9 mm and the edges of 90 degree we fillet in order to achieve desired result. Screw door part. We sketch 2 diameter and extrude to the top 32 mm and then thread the 32 mm. Next, sketch head screw with the shaft of hexagonal size of 4 mm. Other than that, hinge part. We sketch rectangle with 39 mm and 13 mm. Then we extrude 0.5. Then on the top we sketch small rectangle 8 mm and 10 mm. Then extrude to the top 12.5 mm. Then fillet to the top 4 mm. Then do small circle diameter 2 mm and thread the circle. Okay, for the last part I present, nut part. First sketch 2 diameter and then sketch shape of hexagonal size 4 mm. Then extrude to the top 1 mm of the wool sketch. After that, we sketch back the 2 mm diameter and extrude cut it so that we can do a thread.
Okay, I will explain about screw drum holder part of the screw head. We use a 6 shape and a side is 4 mm. The height of the screw head is 1 mm. The height of the screw body is 6 mm and the diameter is 2 mm. If you can see, the thread meets full the screw body. Okay, next the drum part. We use 4 circle to make a outer, middle and inner part of drum. The outer diameter is 135 mm and the middle 130 mm and 133 mm diameter, and the inner part is 120 mm diameter. Okay, the height of the outside of the drum is 165 mm and the inner is 155 mm. We can see the small circle in the inner drum is 5 mm diameter to hold the motor. Okay, drum holder part. We use 67.5 mm radius to hold the drum, and the height of drum holder 95 mm, and the width of drum holder is 160 mm, and the height of leg drum holder is 3 mm. Near the bottom of the leg drum holder, we use 2 small holes with a diameter 2 mm to place the screw drum holder. Width of leg drum holder is 140 mm and the diameter of all drum holder is 135 mm. Okay, next motor part. The height of head motor is 50 mm and the height of body motor is 10 mm and the height of bottom motor is 2 mm and the size diameter of motor is 40 mm and the size diameter of head motor is 5 mm and the size diameter of bottom motor is 10 mm. We use 6 holes of this motor. The size is 2 mm radius. Okay, motor holder part. The height of motor holder is 70 mm and the width of motor holder is 40 mm. The interior distance of head motor is 24 mm and the outer is 30 mm. The thickness of motor holder is 20 mm. We have shape at the head of motor holder and the size is 30 mm. You can see the part of motor holder.
Okay, the last part is soup case. As you can see, soup case has a rectangular shape. Okay, first of all, we make a two straight line which is 20 mm and 25 mm. After that, we make a two section of rectangular inside the diameter that we already shown, which is 13 mm plus 8 mm, and the next one is 16 mm plus 9 mm. After that, on the front view, we make a hole with 3 diameter and we fillet the section 4 mm into 2 mm fillet. Okay, after we make all the parts, the next step is to assemble it. Okay, from you can see from this slide, this is all the parts that have been assembled into one object, which is a washing machine. So this is a video for exploded view of our part. Okay, the next slide is exploded view and part list. As you can see from the slide, we actually have a total of 15 part, which is all the parts have its own quantity. For example, part 14 have a 2-part quantity. Okay, so you can see next is this exploded view of our washing machine. As you can see, there's a body part, there's a glass, and so on. That's all. Okay, next is exploded view. For those who's wondering what is exploded view is assemblies by moving component out from the assembled position. You can use exploded view to balloon an assembly using an item number found in a parts list or bill of material. Okay, exploded view by using a combination of assembly, presentation, and drawing and files. A view of assembly is created in the presentation file and the components are creasy positioned in the view. Drawing views are then generated from the presentation file. The last but not least, conclusion. Conclusion that we can find from our task, which is we learn how to design 3D mechanical part using an Autodesk. After that, we also learn basic of computer aid design and design drawing schematic of product. We also hope that our skill using an Autodesk can be used in the future. Autodesk Inventor professional software provide us a few skill, which is to make a tube, pipe, and so on. Road design automatically compile with user design rules to reduce error and save time. That's all from me.